Yeah. All right, what's up, guys? So today I'm going to show you, actually, I got a guest, Mr. Brewer here, is going to help us out because there's some math involved with this. We're going to do a plaster mold that we're going to create something out of clay. And this is Mr. Brewer's creation. Since he's our guest, I let him do the honors. So we're going to make something out of clay, and then we're going to use plaster to create a negative mold so that we can then replicate and make a series of this same thing over and over and over again. So there's a couple things that we have to math with. So we're going to get to those later. The first step, the first thing that you have to do is you have to create your original. And like I said before, this is Mr. Brewer's. So he's got this thing, this face made out of clay. And I made sure to tell him that one of the important things to do is to not have any undercuts.
Put it up there where they can see better?
Actually, grab the laptop and bring it.
Okay.
Bring it closer. Whoa. I hope nobody got seasick. So, this is the thing, right? Now, the important thing is that if we cut this right down the middle like that and then look at a cross section of it, there's no undercuts. And by that, I mean we're going to cover this whole thing in plaster. This is weird. I don't need that yet. So we're going to cover this whole thing in plaster. I'm going to build some walls around it. What we don't want to happen, so you notice how his nose doesn't have nostrils, because when we pour the plaster in, the plaster would go up those nostrils, and then two things happen. Number one, you destroy your model. This would be destroyed when you take it out, but also those nostrils, you wouldn't be able to get around them when you take the imprint. Am I explaining that well enough, do you think?
Yeah, so you're saying we're going to pull out the plaster, we're going to pour the plaster, and then we're going to go to the bottom and try to pull this out of the plaster.
Yeah, so
And
if this is a cross section, you can have whatever you want going on like that. But if you do something where it goes like this, like under and around, when you pour that plaster in, it's going to fill that, and then your mold is not going to work properly. So you can't have anything where the hole or the cavity is going up underneath
like no
the plaster.
Overhangs.
No, yeah, there you go. No overhangs. No overhangs. So here we've got our clay model. Shout out to Asia for us using her plate. So now that this model is made, what I'm going to do now is I'm going to take some foam board and I'm going to build a wall. It's going to be a great wall. A magnificent wall. And Mexico's going to pay for it. I'm going to build a wall all the way around this thing. I'm kidding. Mexico's not going to pay for it. Warren Consolidated is going to pay for it, and it's going to be out of foam board. So I'm going to hot glue not only these pieces to the foam plate, but I'm also going to seal all the corners. Because when we pour the plaster in, it's got to be a tight seal. There can't be any leaks coming out. So I'm going to go do that. I'm going to do it quick because I got my Sonic shirt on, and I'll be right back. All right, so I've got the box built. And again, I did a line of hot glue at the bottom of each piece, and then there's hot glue going up here on the sides. And if I want, actually, a thing that I can do to be absolutely certain that I'm not going to have any leaks is I can take another little piece of clay and I'll just coil this out and I'll actually use it in all the joints So I'll just take this little coil of clay and I'll press it into the corners all the way around this box. So I just thought about this. Otherwise, I'd have done it while the video was paused last time. So you can see how that works there. So I'm going to go around all the bottom corners, and then I'm also going to go up the sides.
So that prevents the plaster from possibly leaking through.
Correct. So if there's any spots that I missed with the hot glue, this will help. So I'm going to pause it again and again. I'll make this quick. So here we are. I got all my corners sealed. Now, there's the first little bit of math that we have to do. We have to find the volume of this container, because when we mix our plaster, there's three possible outcomes. We want one. The first possible outcome, you need to see my face for this to see how disgusted I look at the two outcomes we don't want. So first, the thing that we don't want that's a possibility is if we mix our plaster, we don't mix enough. And then we've got like pieces of our clay model sticking out through the plaster. We don't have a full form. We're toast. We got to wait till the plaster dries, break it apart, and then mix more plaster. And that's going to take you days. That mistake will literally cost you days on this project, and you don't have that. The second no good outcome is if you mix too much plaster and then you fill this and then you've got a whole other container full of plaster. Now this is going to dry. This is going to dry. This is fine, but now you've got this mess of extra plaster that you have to deal with. So again, that's going to take you maybe not days, but a good half hour extra to clean that, or do what people do and they just leave the stuff laying around. If you want to drive me absolutely nuts, do that. Don't. So ideally what we want is we want to mix the perfect amount of plaster so that we pour it in and we don't have, if any, just a small amount of leftover that we can just dump out in the garbage right away. Also, for God's sakes, don't let any of this plaster go down the drain. You'll see why, but it'll plug up faster than if we let clay go down the drain. So, volume, right? Get your cell phone out real quick. Mr. Brewer is still here, but he's hiding from the camera. But he's going to flash in front. He'll show you how to find the volume of this thing. However it is you built. So you maybe did your face a little bit differently, a little bit bigger, a little bit smaller. So your volume is going to be different than my volume. So get your cell phone out, get ready. Mr. Brewer, flash that thing.
Okay, so because the shape that we made our wall out of is a rectangular prism, we could actually just use the regular volume of a rectangular prism, length times width times height. But it's important that we measure this in centimeters, and we'll explain why in just a minute. But you'd have to measure the length, width, and height of your container first, and then calculate the volume from that ruler.
So as much as it bothers me, I don't like the metric system because I don't use it. I don't know, like a centimeter, you might as well call it a falafel measurement or whatever. It doesn't. So the size of this is a sucky ruler because it's got like a little extra tab. So how big is that extra little tab? It's like a 1/2 centimeter. So check, some of the rulers have an extra little thing. So I'm going to take my measurement and then I'm going to add a 1/2 centimeter. So it's at 5.
They all have that.
So yeah, I don't think I have any that don't have that extra little tab. So the height, so I want height, and I want length, and I want width.
Where's that other ruler?
Right here.
Oh.
So it's like a 1/2 centimeter. Is that
Yeah, that's exactly what it
cool?
is. So it's 1/2 centimeter extra.
So when I measure, it goes to 5. So my height then adding that extra 1/2. My height is 5.5 centimeters. Now when I measure on the inside, the length and the width, I want to measure from the inside. Don't measure the outside.
Because there's no plaster on the outside.
Because there's no plaster on the outside. And the foam board has a thickness. And we don't want to include that in our calculations.
Do you know what we could have done easier? Is we could have measured the height before we built the wall.
Oh, yeah. So that's something that you want to do. You can do that.
Learn from our mistakes.
That's it. So I'm at 10. And again, I'm measuring. I don't add the half because I started at the 0 this time. So I'm 10 inches wide. Or I'm sorry, nope, 10 centimeters. I'm going to do that the rest of the day. I'm going to be calling it inches. And our length is 13 and a half centimeters. So now I'm going to pause the video. Actually, we don't even have to. I'll just use my phone, right?
Yeah.
Length times width times height. So my clear length is 13 and a half times 10 times 5.5 equals 742 and a half. So that's the volume now of this box, of this cavity. And of course, like, the face is taking up a little bit of that volume, but it's not going to be enough where it's going to be problematic for you. So the next step is mixing the plaster. Actually, the next step is using math to calculate what this means for how much plaster to calculate. And this is where Mr. Brewer is going to kind of help explain it. I know how to do it, but to explain it is still, like, I don't know it well enough. So
so what's the problem that we have to solve? What's the issue?
So now we got to figure out how much plaster we need.
Right, and the problem is that plaster...
Come into the video, man.
Okay. Hi. So the problem is that plaster and water kind of expand. So, for example, if we were to fill up with water, just fill up our mold with water, and then add more plaster, that's actually going to take up even more space.
Right.
And so what we need to do is actually add less water.
That's right, because the volume in cubic centimeters is the weight also, right?
Of the water, yeah.
Of the water. So that's why we're using metrics, is the 742. You can't see that. So when I point to it, it doesn't make sense. So the 742 and a half, what is it?
Cubic centimeters.
That's
cm
with a cute little 3 on the top, right? So that's the volume, but it's also the weight.
Right. So
in metric system.
Now we're going to ignore the actual fact that the face is going to take up some of that space because we don't have a good way of finding out how much space that is. Okay,
and it's negligible for how much space it's going to take up.
Yeah. So for those reasons, we'll just find the volume of the container, but we don't actually need to put in all of that water. We don't need 742.5 cubic centimeters of water. We need a little less than that because then we're going to add plaster, and that will grow the volume up to the whole amount.
Right.
So
we need 742 cubic centimeters of water plaster mix.
Exactly. So because plaster expands...
Get out your cell phone, take a picture.
Here we go. Because plaster expands, we need less than the volume of the whole container. And so it's actually a proportion, like you learned about in Algebra 1.
Boom.
So 100 cubic centimeters of water will turn into 120 cubic centimeters of solid plaster when we're all done. So, because what we want to find out is what is the unknown amount of water we will need in order to fit inside of our volume of container. So, I have also set that up here for us. So, for our case right here, We have 100 cubic centimeters of water over 120 cubic centimeters of solid plaster equals X over 745.2, which was the volume Mr.
No,
Brown
it should be
calculated.
745.5.
Sorry, I can't
0.5.
read backwards.
Right.
Okay, yeah, 745.5. Okay? 742.
742.
I wrote it right.
Okay.
I'm
good.
not crazy.
So our math is going to work out despite
Yes.
our inability to use the English language.
So now we are going to pause this video and solve the proportion, and you should try to solve this proportion on your own.
Because your number is not going to be 742.5. It's going to be different.
Yes.
So, we'll be right back. So now we're at a part where we're going to be actually pouring plaster. And it's very important that you use a mask. And also, if you're doing this in class, make sure there's nobody around your general area when you're doing this, because the plaster dust, like clay dust, it stays in your system forever. So you want to prevent as much of that from getting into your lungs as possible. So Mr. Greer and I both, see it? We both have our masks on, and our glasses are steaming up. But that's okay. Small price to pay for safety. So I did my math, and like these numbers seem outrageous, but the plaster has so much air in it that like it's going to seem like you're using an excessive amount of plaster for this.
It's kind of like, you ever dissolve water in
Dissolve salt in water.
salt in water, right?
Yeah.
It's not like the water's volume changes a lot, right? So
Not even noticeable.
yeah, so plaster will change the volume a little bit, just not a crazy amount. Yes.
You heard it here.
There you go.
So, based on the volume of our box, I've calculated it with the help of Mr. Brewer that we need 618.75 milliliters of water, and your plaster ratio is going to be 2 to 1, so 2 parts plaster to 1 part water. So that means that we need 1,237 and a half milliliters of or grams of plaster, right?
Yep.
All right. So with this scale, what I can do with most scales, this is the container that I'm going to use to measure my plaster in. I'm going to put it on the scale, and then I can hit a button and it zeroes it out. So it's not actually measuring the container. So I put the container on, and the container weighs 76 grams. But I zero it out, and now the scale, even though the container is on it, it's reading at 0.
So you're going to do plaster first?
I'm going to do plaster first. And I need a...
Thing about that is...
So, I'm going to put my plaster and water mix in this bag, and then I can agitate it a little bit and mix it up and still keep it kind of clean. So, all right. So we're at 0, and then what I'm going to do is I'm going to use this. I'm going to put this strainer over top, and I'm going to pour my plaster in.
Zero it again.
Yep, you're all right. There we go.
Actually, you didn't have to zero it again.
Oh,
Unless
yeah.
you're just gonna, if you're gonna take it out again. But now if you zeroed it again, then the strainer has to be placed on it
Yeah.
at the end.
Which is fine.
Yep.
So right now I'm just getting plaster all over my computer.
Oh, I could have done that.
So I'm just pushing the plaster through the strainer.
So why does the plaster need to be pushed through the strainer?
If there's, we don't want, sometimes the plaster will start to clump up in the bag. So we want to prevent any of those clumps from getting into our mix, because that will affect how the plaster pours.
So like when it's salt or sugar, you dump a cube in, the cube will eventually dissolve the whole way, right? But are you saying it doesn't work like that for plaster?
That's actually a really good question, because there's a chemical reaction that happens with the plaster. Like if you mix salt and water, you can get the salt back out, right?
You're
if the
right.
water
And
evaporates.
so that's not a chemical reaction. That's true.
So, and you'll feel it's crazy as you mix your plaster. When you start to add the water, you'll actually feel it heat up. All right, so I have 188. So this is, it's going to take some time. But I can feel some of those clumps in there. So those clumps have already reacted to moisture that's in the plaster, right? Moisture that got into this container. And there's no way to undo that. So I'm going to do this one, and then I'll pause the video. I'll finish doing this so that you don't have to sit here and watch me. All right, so now I'm at 449. So I'm just going to write down, I'm going to do these in increments. So there's 449 grams.
You mean because you've run out of space in the...
Or yeah, because I've run out of space.
Yeah, okay.
So I need 1237. So I just take 449 and subtract it from 1237. That tells me how much I have left to go. So dump that plaster in there. Right, that's... I'm going to zero it out again. And when I return, this bag will have 1,237.5 grams of plastering. All right, I forgot. So because my scale doesn't have halves, I just rounded up. So there's 1,238 grams of plaster in here, which that extra half of plaster, if the ratio is not perfectly a 2-to-1 ratio, your plaster will still mix. It just, if you have more water than plaster, it takes longer to solidify.
All right, so maybe this is a good time for me to step in.
There you go.
Okay, so here's the problem. We know here how many grams of plaster we have, and we know we need half as many grams of water, and that would be 618.
618.75.
So 619
right.
grams of water. So I guess we have two choices. We can either use the scale to measure out the mass of 618 grams of water, or we can just measure the volume because this is a measuring cup, and we'll be able to get it pretty close. We just have to be careful that we don't use the English side, and that instead we use the metric side, because here's the thing. All of this is only a way of measuring volume on here. So we're taking advantage of the fact that 1 gram of water is the same as 1 cubic centimeter or 1 milliliter of water. They're exactly the same amount. That's the advantage of the metric
As
system.
much as it pains me to say so, it is kind of handy.
Yes. So anyway, but you have your choice.
Let's not use that. Since we have 2 of them, let's keep the plaster one for plaster, and we'll use this one for water. So now we're going to measure out. What are we going to measure out? 618.75 liters. Milliliters.
Yep.
You don't do liters. That's going to be a lot of water. Milliliters of water. So I'm going to measure that out. I'm going to put it in a separate container, and then I'll show you how to pour it in and how to agitate it to mix it up. So sit tight. All right, so we stopped, and just for fun, we wanted to check. I bought these at the dollar store, no surprise. But Mr. Gruer pointed out, like, these things roll through an assembly line, and they get printed wherever they get printed. This is probably not very accurate, and I never thought of it. So when I used the milliliter line, and I filled it to about where I should be.
Yeah, between 600 and 650, right?
I was way under. I was at like...
And how did you know?
530 grams, because I measured it on the scale. So just like the plaster, I zeroed out the pitcher first. Oh, there you go. I zeroed it out, and then I measured it. So I was way under where I should be.
So we thought that we had, 618, according to like the lines on the measuring cup.
Right.
But when we measured the mass of it,
it was not
it
correct.
was actually only 530 milliliters. And we know that, again, because 1 gram of water and 1 milliliter of water are the same amount.
Samesies.
Yes.
So what we did, we took this back to the sink, filled it up to where we thought it should be. Now I'm over. So I've got an empty cup here.
Yeah, so the mass says 665 grams, which is the same as 665 milliliters.
Right, and we need to be at 619.
Right.
So now I'm just going to take this empty cup.
Yep.
I'm going to scoop some water out. And I'm
now
at
it says you're at
582.
So you scoop
now
out
I can
too much
just
water.
Whoop.
590. 600. 609, 610, stop. 621. That's pretty darn close. Can
Yeah,
you pull
take
out
a little bit.
618.
619, perfect, right on the money. So again, I told you it's not a big deal if you're not exactly at a 2-to-1 ratio, but really, to make your life easy, you want to be as close to that ratio as you can be.
And that's a real easy way to basically adjust the amount of water you have to be very consistent.
Right. So before I start to mix, so here's my bag of plaster. Here's my 619 milliliters of water. Yeah, tip it down.
Is that right?
Yeah. You see that I've got plaster everywhere, and I'm still wearing my mask. I really want to take my mask off because it's not super easy to breathe. So what I'm going to do is, to get the plaster off of my hands, I'm going to take brown paper towel, I'm going to get it wet, and I'm going to just wipe my hands with the wet paper towel, and then I'm going to take all of this stuff and I'm going to tap it into the garbage can.
Wait, so you're not going to wash your hands in the sink?
I'm not, because if the plaster powder gets down the drain, it's going to clog up.
So this stuff looks just like innocent, but it'll actually screw over our drains.
It'll screw over our drains, and it'll screw over our lungs. So again, that's why we're being super careful. I'm not being extra. I mean, I am, but it's for a reason. So I'm going to pause the video. I'm going to clean this all up, and then I'm going to show you guys how to mix the water into the plaster, and then we're going to pour it into our mold. All right, so I've cleaned up. No plaster went down the drain. I've got my 1238 grams of plaster, my 619 milliliters of water. So what I'm going to do now is I'm going to mix this, and then once I've mixed it all the way, I'm going to pour it into my mold. And if my math was done correctly, there should only be a little bit of overflow and not a lot. So here's the mixing. Now you notice that I still have my respirator on, because there is a chance when I pour the water in that there might be a dust cloud that comes up. But once I pour the water in, I seal the bag. I'm probably pretty safe to remove my mask. So I'm going to try to get as much air out of this bag as possible. Without losing any of the materials inside. There we go. And I'm going to kind of make sure that all the plaster from the corners, make sure there's no lumps. Any lumps that I feel, I'm going to try to massage them out so I can take off my respirator at this point, because there is no more dust in the air. And I'll get rid of more of that air that's in the bag. I'm going to keep breaking up these lumps. Now you have a limited amount of time before this plaster starts to react with the water and it starts to become hard. So I'm going to keep mixing. It's very liquidy right now. And what's crazy is, you remember how much water and how much plaster we put. Right now, like that's all the material that we have. It looked like it would be a whole lot more. But as the plaster, what would you call it, gets aggregated into? Would that be the word? As it gets aggregated into as the plaster becomes part of the water, the volume of all of this becomes much less than the sum of the two separate parts. Still got some clumps in there. Now you want to be careful too, when the plaster begins to harden, you'll feel it heat up. So I can feel the plaster starting to thicken. It's still, right now it's about the consistency of maybe thinned out pancake batter, whereas when we started it was very, very watery. So in a minute here, I'm just going to continue to mix and agitate. Checking to make sure that there are no clumps, and then right before I pour it in, I'll start the video again. So I'm going to keep doing this until it thickens up a little bit more. Not much, but a little bit, because the thicker the plaster is, the less likely it's going to be to seep into or around or through any of those little holes. It'll stay in this form a little bit better. So I'm going to keep mixing, and then when I catch back up with you, I'll be ready to pour. All right, so while we were, Mr. Brewer here, talking, looking up the chemical nature of plaster of Paris, and he came up with a ratio of plaster to water that's actually smaller than 2 to 1. So bigger than, so there's more. You should have more plaster to water. But for what we're doing, it's easier to do the 2 to 1 ratio. But at this point now, I'm about ready to pour. So because we use the 2 to 1 ratio, the plaster is very liquidy. It'll still work. It's just going to take a little bit longer to harden. But as I pour this, I want to make sure that the plaster gets, I'm pouring right over the face that we've made. And I'll make sure that all of that there's no little pockets or bubbles. So we've got a small amount of plaster left over in the bag. Actually, more than we should. I don't know how that happened, but anyways.
Do you think it's because of the water not having evaporated yet, or do you think it's because of the face in the bottom?
I think it's because of the face in the bottom and because of the clay that we wedged in the corners too.
Oh yeah.
So what I'm going to do now is I'm going to take this and I'm going to shake it, because as we pour, as evaporation happens and as this chemical reaction happens, there are air bubbles that are created. And you don't want, if those air bubbles attach themselves to the clay sculpture, when the negative is pulled out, it'll look like pock marks all over the sculpture. So I'm just going to shake, rattle, and roll, and you'll see these air bubbles kind of rising to the top. Just small little bubbles. And I'm going to keep doing this until the plaster begins to harden. And it shouldn't take more than 20 minutes or so. But at this point, I mean, if you shake and agitate for 15 minutes or so, you should have all of the air bubbles out. So I'll show you what I'm talking about. So you can see there's some air bubbles here and here, and as I shake this, you'll see those bubbles start to rise to the top. They'll start to show up. See all those air bubbles right along there? I don't know if you can or not. You got some up here.
So the amount of shaking required is not large, it looks like.
No, it's not. Just enough to shake those air bubbles loose and get them to rise to the top before the plaster starts to harden. And as you're doing this, if you notice that I've been doing it for a couple minutes now and I don't see any more air bubbles coming up, then you're probably good. So I'm going to keep shaking a little bit more, and then once it's dry, I'll be able to take this apart and do my mold from there. So now you know how to do up to this point. and then I'll probably do another video where I show you how to remove the mold and actually use it to make imprints of your sculpture. So good luck, have fun. Remember, wear your respirator, don't get this stuff in my sink. Peace out.